Welcome into Perfect Media Server Part 3. Yes, we are finally doing this. This is going to be a full step-by-step guide video on how to install a fresh Proxmox system and install a working Perfect Media Server base on top of it. This video is very detailed. Pause it, follow along, come back to it when you're building your own box. But by the end of it, the machine should have Proxmox installed and updated. Your data disks should be identified, formatted, partitioned, and mounted. We're going to go through all of that complicated process in detail today. We're then going to use MergerFS to pool those disks together into one storage path. And then we're going to use SnapRAID to calculate parity and do checksumming across those drives. Finally, once all of that is done, we're going to use Samba to make those files available across the network and then set up a Jellyfin server using Docker towards the end. And we're right in the middle of Jellyfin June, a month-long channel takeover where we're covering all things Jellyfin. So it seemed fitting to me to do the Perfect Media Server Part 3 right now so we can point folks at this guide so they can build their own media servers from scratch. Not that long ago, the parts in this box I basically considered scrap. But in 2026, with the prices of hardware completely out of control, these parts now have a new lease of life. So instead of Perfect Media Server kind of sliding slowly into irrelevance because hardware was getting so capable and so cheap, we kind of need it now more than ever. Constraints, and in this case the constraint is the state of the hardware market in 2026, breed creativity. Now it's worth saying at this point that Perfect Media Server is not a verbatim guide on how to do things. In fact, I'm largely about to recap at a high level what we covered in parts 1 and 2. So Perfect Media Server is not a single operating system or appliance, although we talk about Proxmox a lot throughout this series. Really what Perfect Media Server is a set of open source tools arranged around a few practical goals. We want to store lots of media on mismatched hard drives. We want to add storage one disk at a time, because Lord knows it's expensive enough. We want to keep each disk individually readable with its own file system, which means we don't need to worry about things like striping and buying entire batches worth of drives at once to build the perfect ZFS artisanal grade array. We can just buy a drive from a thrift store for $80 and throw it in our server and call it good as our budget permits. We also want this to be a platform for self-hosting apps cleanly using containers. And the trade-off here is that this setup is more work up front. You've got to learn Linux and Docker and the command line and remote access and how to partition disks. The upside is, number one, hopefully you'll learn something. Further down the road, you end up with more control and flexibility. There are no license fees, there can be no rug pulls, and this system will just grow with you over time. So for those of you that didn't watch parts 1 and 2, which are linked in the playlist up here in this corner, I'm going to do a quick tech stack recap for you all. Proxmox is the base OS, and we picked this because it's basically just Linux underneath. It's based on Debian, and it gives us a very easy to use web UI for managing the server. It also gives us ZFS out of the box, in addition to everything else that Linux supports, without having to drop back to something like DKMS. Now, even if this is mostly a NAS, we can also use Proxmox to run things like VMs and LXCs and get, if we want to later on, we can start getting involved with things like clustering and infrastructure as code as well if we want to. So it becomes a learning tool, not just a media server, although of course if that's what you want this thing to do, as we will cover throughout this video in excruciating detail, that's exactly what it does. The next piece of the puzzle is MergerFS. This is the drive pooling layer. So this is what allows us to take the multiple disks that are in this system and merge them all together into one mount point that we can point our media server at. So rather than having to tell Jellyfin, right, you need to look on disk 1, disk 2, disk 3, we can just point Jellyfin at the single storage point that MergerFS creates. And the best thing about it is that it works with mismatched drive sizes. So in this box, I've got an 8 terabyte on the drive on the desk in front of me. There's a 12 terabyte, a 10, and a couple of 4s. Like, you can just throw whatever you've got. And the most important thing about MergerFS, beyond its flexibility, is that each disk keeps its own normal, individually readable file system. So that means if you have a disk in here and you pull it out and go and stick it into a different computer, you can read it, not like a ZFS or traditional RAID array where everything is striped across all the disks, and unless you have all of the disks available, it won't be happy. The benefits of that are legion, honestly. So like I say, you can take it and just shove it in another computer. That's great for backups, for offsite backups. It's also handy for performance because you're only reading off one disk at once. Now that might sound like a bad thing, but in a media server, typically you want all the TV shows and the movies kind of co-located together. Like, you don't necessarily want all of the episodes of Friends or whatever it is scattered across 15 different disks, because it keeps all of those disks spinning at all times. And these things don't use a ton of energy, but maybe 5 watts continuous, and at roughly $1 per year for 24/7 operation, you know, $5 times 5 or 10 drives adds up pretty quickly. So with MergerFS, we can spin down the drives that we're not using to save on our energy costs as well. Now, if one of these drives fails, it's not really a question of if, but when one of these drives fails, we need something to calculate parity for us. And that's where SnapRAID comes in. This is the parity and checksumming layer. MergerFS by itself doesn't protect the data. This is in contrast to something like an unRAID that does have many of the same features we've just talked about, like mismatched drive size support, but unRAID does real-time parity calculation, whereas SnapRAID adds snapshot-based parity calculation. So what this means is if a data disk fails, you know, this one decides, my charity shop disk decides it's only going to last me for a week, I can rebuild from the last known good SnapRAID sync. It also has the benefit of checksumming files and is great for media because media libraries are usually write once and read many. SnapRAID isn't the best fit for things like databases or busy data sets where you've got lots of app data churn and things like that. But for media files, fantastic. Now, ZFS is optional, but it's useful for critical data, for things like photos, documents, app data, that kind of thing. Anything you genuinely really cannot afford to lose, ZFS is still the gold standard, and MergerFS will work perfectly with ZFS as well. Snapshots and replication make it especially useful for container configuration and backup workflows as well. And we're not forcing every media disk into ZFS because Perfect Media Server is designed to grow flexibly. But if you want something that's going to be reliable and stand the test of time for your most critical bits, I cannot recommend anything more highly than ZFS. Then for the application layer, of course, we're going to turn to my old friend Docker. Docker keeps apps isolated from the host and from each other. Persistent data lives outside of each container, which makes application rebuilds and upgrades a lot less risky and a lot less painful. And with Docker Compose these days, we can define apps in YAML, and keeping the configuration for those containers in Git makes recreating services really easy and predictable. This is how we'll run the app later in the video, Jellyfin. Of course, like I said, we're in the middle of Jellyfin June, so it had to be Jellyfin this time. But you can also run all sorts of other self-hosted apps like Image if you want to do a Google Photos clone, Nextcloud to replace Google Drive, Paperless to store all of your tax documents and that kind of thing. The world of self-hosting is rich, and I am so glad you're here to get started on that journey with me today. Now, this guide is deliberately manual. Perfect Media Server, like I say, is not a one-size-fits-all type solution. The point of today's video is to teach you the skills you need to take a random bunch of parts off Facebook Marketplace and turn it into a server. I'll show you how to use things like stable disk identifiers, not temporary names like dev SDA, because I don't know about you, but I've had many occasions where my drive letters just change and then my system won't boot. And as I say, you can expect your hardware to be different from mine. And I'm deliberately not going to get too much into the hardware that's in front of me today, but I will tell you what the specs are. So the specs of this system are very modest, honestly. It's an i5 8500 CPU with 32 gigs of DDR4 memory. There is in here a motherboard which is a little bit more fancy than I honestly need, but I've had this motherboard in my possession now for several years, and I bought it in the before times, so it was much cheaper. But this is the ASRock Rack E3C246D2i Mini ITX motherboard. This case is the Lian Li PCQ25B, and again, I've had this case in my possession now since I lived in London a decade ago. This just lived under my stairs and happily did its thing, and now it's kind of relegated to demo duties on the YouTube channel, and for a long time actually this was my local on-site replication backup target, but now I've since moved that to a friend of mine in Canada, so I replicate all of my data off-site, but this has served me very well for a great number of years actually. It's got some nice features. It's got a backplane for the discs. It can take 5 spinning drives. It takes a 140mm fan up front and a 120 at the back. It's quiet. I think you can pick them up used for about $130. It depends on, you know, where they are, what shipping is and stuff like that. But if you set your filters on eBay right, you can still find these wonderfully made. Like Leanne Lee, sort of 10 or 15 years ago, the fit and finish of their cases, this is very similar to the N-Case M1 if you had one of those, uses the same push pins to put the side panels on and off as well. Now the reason this motherboard I consider it to be a bit more fancy than honestly you might need is because it has built-in IPMI, which means I can remotely manage this system over the network. But these days we have things like this. This is the Jet KVM. This is a remote IP KVM box. It's about, I don't know, the screen's about the size of an Apple Watch. And this can send keyboard and mouse commands to this, as well as transmit the video out from this server across the network, which means you could now use consumer grade hardware instead. So I had a quick look for an 8th gen Intel compatible motherboard, and I found the ASRock Z370M ITX for around about $130 used. You pair that with the i5-8500 CPU I have in here, which you can find used for an unbelievable bargain of about $35 these days, and it's an absolutely amazing value for what you get. So depending on the decisions that you make and the deals you find, you can absolutely build what's on the bench in front of me for probably, depending on the deals you get and the drives you find. Without the drives, it's probably about $500. And then with the drives, well, the sky's the limit. But, you know, for a modest set of used drives these days, you can probably budget in the 100 to 150-ish range per disc. It's time to do a step-by-step guide walking you through a fully manual setup of a perfect media server. So by the end of this section, you will have a fully functional Linux system that you can do with whatever you want. We're going to install the base OS together. We're going to learn how to partition drives. We're going to learn how to mount our disks in Linux and use MergerFS to mount them and merge them all together, as well as some other stuff like setting up Samba and your first Docker container as well. So let's get started without any further ado. There will of course be chapters down below, and I'll try and line up the chapters in the video with the headings in the perfectmediaserver.com article that this whole thing accompanies. Before we install Proxmox, I just want to take a second and touch on the fact that there are 2 different ways to install Proxmox. Because of course there is. This is Linux world. There's always 5 different ways to do everything. But there are 2 supported ways to do this. One is to download the Proxmox ISO from the Proxmox website. That's what we're going to do. The other option is to install vanilla Debian and then install Proxmox on top of that. Now, I should say, before you proceed, I want to make sure that you've disconnected any data disks or any unimportant drives from your system whatsoever. This is to avoid accidentally installing Proxmox onto the wrong drive and overwriting any important data. Now, Proxmox do provide a full installation guide on their website, so this is going to be a very high-level overview, including their official method for creating a USB key. But, broadly speaking, the process is go to proxmox.com/downloads and download this ISO file here. Yours may not be 9.2, it might be 9.3 or a later version. That's fine, the steps should be the same. You'll then want to grab a USB drive, and this one has a neat trick up its sleeve, because on one end it's USB-A and on the other end it's USB-C, which means I can connect it to my MacBook to flash it and then drop it straight into the server to boot from it later on. So download the ISO and it should appear in your downloads folder like so. Then take your USB drive and insert it into your laptop. Once inserted, the drive should show up as normal in Finder on macOS or Windows Explorer on Windows. Then you'll want to download an application to actually write the ISO file that we just downloaded to the USB key. And there are 2 options to do this. One on macOS that I like is Balena Etcher, and you can find that at etcher.balena.io. It's completely free. And on Windows, if you're playing along, you can use Rufus to do the exact same thing. You select the physical device, then you select the ISO you want to flash, and you flash that to the USB drive. So let's load up Balena Etcher, and it will look something like this when you load it up for the first time. Click on Flash from File, navigate to your Downloads folder, or wherever the ISO is if you put it on your desktop or whatever. Then select it from the list, click Open, select target. This is where we select the physical USB key itself. Make sure you pay attention at this step because it is easy sometimes if you've got multiple devices connected to overwrite the wrong one. And bear in mind, we are about to destructively write everything off of this USB key to become a Proxmox install key. So pay attention at this step because you can initiate a foot gun if you're not careful. And now click flash. It's going to ask me for my password, and this is my laptop password, simply because we're doing something that requires elevated privileges, writing to external media and zeroing out the partition table and basically flashing an image. Now this process here takes about 30 seconds on my USB stick. It depends on how fast your USB drive is as to how long it takes. Sometimes it can take 5 minutes. So flashing will continue now. It will then verify what it's just flashed to the USB drive, and then it should be complete.
A few moments later.
And if everything went according to plan, you should see a screen like this where it says flash completed. So we can now remove our USB drive from our laptop and go and put it in the server. Now your server's probably powered off at this point, and that's fine, but now we need to figure out how to actually get access to the physical machine. So we're going to need a monitor and a keyboard at the very least. Now I'm going to cheat today. I'm not going to use a physical keyboard and mouse. I'm going to use something called the Jet KVM. This is what's called an IP KVM because it lets me access the physical inputs and outputs of the system over the network. Now this board happens to also have built-in IPMI as well, so it's like double redundancy here. I only use the built-in thing to do power on and off commands. Most consumer boards do not have built-in IPMI, so I'm kind of not going to cover this too much in the video, and I don't want to confuse folks thinking you have some hidden menu that you don't know about. Most motherboards do not have this. But simply all I'm using Jet KVM for today is to take the place of a physical monitor and a keyboard on my desk so that it's easier for me to record this video and show you what's going on. So once you've pressed the power button on your system, physically or otherwise, you're going to want to bring up the keyboard. Now I like to do the virtual keyboard just so that I can be absolutely sure that there aren't any, my laptop isn't trying to capture F11 to do volume control, for example, like it likes to on macOS. So I like to I literally just like to keep hitting F11. I happen to know that this is the key that gets into my computer's boot menu selection screen, and that's where I can select to boot from the USB drive or indeed any other bootable medium in the system. I'm just going to keep spamming F11, and you can see I've finally entered the boot menu down here. I had other options to get into the BIOS with delete and F2 and all that kind of stuff. But we're now at the point where we can actually select the device we want to boot from. Now, you see, I could boot from the Jet KVM virtual media if I wanted to, but given we just flashed a USB drive, why don't we use that? It's also important to make sure that you select a UEFI option if you have it, rather than this one. So if it just says SATA or something else like that, and it doesn't say UEFI, this is a foot gun that's very easy to do if you don't realize early on in the stage, and it will screw you up later on. Make sure you select UEFI, and this should boot us into directly the Proxmox install environment. And here we go. Installing Proxmox is fairly straightforward, so I'll fly through it pretty quickly. I'm going to select the terminal UI option just because, I don't know, I'm old school. I like a good TUI rather than the graphical environment. It doesn't really matter which option you pick. The options are broadly speaking the same. It just depends if you have a mouse hooked up or not. And oftentimes when I'm in this kind of early bootstrapping stages, I don't have a mouse. Okay, I do have a mouse because I've got the Jet KVM, but you get my point, hopefully. So let's whiz through the rest of the install process. I'm going to select I agree for the license agreement, the EULA. Now I also want to make sure that for my target hard disk, you can see this system actually has two options. One is an NVMe drive, which might be the obvious target. You think, oh, I want to install Proxmox onto the fastest storage available in my system. I'm actually going to install Proxmox itself onto the SATA SSD in this system, number one, because they're cheaper, but number two, this leaves the NVMe drive available for all of my self-hosted applications, for all their media serving database needs, as they're scanning through thousands of metadata files or doing download unpacks and that kind of stuff that needs a lot of IOPS to feel really snappy. So I'm going to select SDA here as the Samsung SSD 850, which, as you can see, is no spring chicken of a drive. In fact, I think that drive's been around in my life for 8+ years at this point. I don't even know. If you want to dig into the advanced options and start playing around with things like ZFS or ButterFS for volumes and versioning and data sets and that kind of stuff, you absolutely can, but I'm going to keep things simple today and just select ext4. Okay, moving on to the next phase. Okay, select my country. By the way, this list goes around the top, so if you're in one of the United Kingdom or the States like me, you can just scroll the list around the top instead of scrolling all the way down 8,000 times. Just a little tip. And now I'm going to select US English. And by the way, that same trick works for this list as well. Okay, next. Okay, time to set a root password. Here we go. And I'm going to select Zaphod at, of course, perfectmediaserver.com. Now we need to configure our networking. So this is where my system will probably differ a little bit from yours. So in the NIC drop down here, you see I've got a couple of options. That's because my motherboard actually has 3 NICs, confusingly. One is a dedicated IPMI network interface, and then the other 2 are just gigabit NICs. I believe they make this motherboard with 10 gigabit base T NICs as well, but I didn't buy that one. I just bought the cheaper one. So this ASRock rack motherboard, I know that this MAC address of D05099 DB2D on NIC 0, that's the one that is being picked up in my firewall and my router, because I use Unify in this house. I'm not saying you need Unify to do this, but it does make moments like this much easier. So if I show you on here, I can see that on port 4, which I happen to know to be the physical port in that switch right down there that I'm pointing at, that's the port that this system is connected to. And I can see that as of 5 minutes ago, this machine with the MAC address of B22D connected to this physical port. So if you don't have anything fancy like Unify, you can probably just look in your firewalls, like ISP provided routers DHCP page, or it'll be in some kind of lease settings page. It's really hard to know because every different firewall or router manufacturer calls it something slightly different. But what we're looking for here is that B22D right here. Now it's up to you for a host name what you want to do. Proxmox wants what's called a fully qualified domain name, so FQDN. But that doesn't mean that you need to own a public domain, although I would probably encourage it for sort of $10 a year or so. You can probably get your own .com or some other WTF or .lol domain that you can use for all of your self-hosting needs. You don't have to have one though. And for a home lab, it's perfectly fine to use a private domain that only exists on your network. A good modern choice for the home is home.arpa. So that's what we're going to go with today. I'm going to call this box rather creatively proxmox.home.arpa. Now, I always like to give my servers an IP address that's on the 10, so like a 10 or a 20 or a 30 or something like that. And so this one is just going to be 1.10. Simple as that. I also know that my gateway address is 1.254, as is my DNS server. So if you have a Pi-hole or an AdGuard home or something like that, make sure you put that in here. And you would find out all of that information inside of your networking world, in my case, my Unify world. So that's the bit I can't really help you with too much. You're just going to kind of have to figure it out, I'm afraid. But essentially what we've done here is we have set a static IP address for this Proxmox installation. So just remember this IP address here of 1.10, because you will need it in a minute to connect Proxmox over the network. Now, if all of this looks good, we can go ahead and get Proxmox installing. And when the installation is complete, you can see that the system will automatically reboot. So this is where you would want to remove the physical USB drive, just so we don't accidentally boot the wrong operating system. And so hopefully this is the moment. This is where we're going to have our first boot into Proxmox. So I hope you've crossed your fingers, toes, eyeballs and everything else, because this is the moment of truth. Well, we're off to a good start. If you see this blue, what's called a grub screen, this lets you select different versions of Proxmox with different kernels and other kind of advanced parameters. You don't need to touch it. It will just automatically progress, as mine did after, I think it's 5 seconds is the default timeout. And we're booted. We made it. Our server booted. We've installed an operating system onto our Perfect Media server and booted into Proxmox. With our first successful boot out of the way, it might be tempting to think we can just head over to our server, install our drives, install a couple of packages, and call it good. But actually, I want to get moved into this server before we do anything too much more. So let's head over to 192.168.1.10, and then we'll do port 8006. We've got to make sure that this is on HTTPS as well. Now we can ignore this scary "your connection is not private" warning because Proxmox by default ships what's called a self-signed certificate out of the box. This is something that it generates internally, and then because of how TLS certificates work, there's no chain of trust. Like, you haven't trusted this Proxmox server's root in terms of the chain of trust stuff. That's why you see the self-signed certificate warning, and that's why it's safe to ignore, is because it's generally been generated on this server, and so we know locally that it's fine. So let's get logged in with our root username and password locally. And this is one of my biggest bugbears with Proxmox, honestly. It's a fantastic project, but putting this kind of annoying little nag screen in the way between me and every single time I log in, I just don't like it. I'd honestly rather prefer like a little Proxmox, you know, banner at the top or something that modifies the logo up here rather than this banner, but it's not too difficult to patch out. So back in 2024, a chap called T-Tech, who unfortunately passed away a couple of years ago now, he was maintaining some scripts that used to do things like patching out that subscription nag, modifying things like the subscription repos for Proxmox to be the free repos, and a bunch of other stuff. As I say, unfortunately, he passed away in 2024, but those scripts live on beyond the man. So we can head over to communityscripts.org. Now, bear in mind, the entire purpose of this website is to present you with scripts to download and run on your server. It is therefore imperative you understand the risks involved with doing that. And likewise with the scripts from perfectmediaserver.com we'll use in the next step as well. So just pay attention to the warnings, make sure you're verifying the sources that are here as well. And you can do that by looking at their GitHub and the links that are used. But all we want to do is look for the post-install script that's here for PVE. There we go, it's number 3 in the list as we record. And if you want to verify the command or verify the content of the script to be sure it is what you think it is, click on the link and verify that the script is doing what you think it's doing. Throw it into ChatGPT. Make sure, you know, if you don't understand this stuff, make sure you've got a way to verify that the code is doing what you think it's doing. And then just copy this command to your clipboard. Simple as that. Then go back to your Proxmox web interface, and I'm just going to make this a little narrower. And then we want to click on the node itself. So we named it Proxmox, remember? I'm going to click on shell and then just paste this into the terminal. This is going to start running the PVE post-install script. So let's do this as the very first order of business. Do you want to run this script? Yes, please. It's detected that modern Deb 822 sources already exist. This is something that with Proxmox 9 and above came into being. This is just where Proxmox gets all of its packages from. There are some enterprise repos as well. So one of the ways that Proxmox makes money is by charging a subscription. And they do that in 2 ways. One is for support, and the other one is for access to enterprise repositories that have more stable packages or something. Honestly, I'm not entirely sure. It's similar to the Red Hat model, I guess, but in the decade plus of using Proxmox, touch wood, so far nothing has gone wrong for me just using the free repos. So I'm going to disable this one, and because I don't want the enterprise repos for Proxmox or Ceph. I want to enable the no subscription repository. Yes, please. And do I want to enable the PVE test? Sure. Do you want to disable a subscription nag? Why, yes. Yes, I do. Now, I do really want you to just stop and think for a moment about supporting the Proxmox project. It's a really wonderful project, and if you find any utility in it at all, find a way to support the software, even if we're going to remove the nag screen. Now, this node is going to be, at least for this video series, a single node. There will be no clustering, or Proxmox allows you to do something called clustering and have multiple nodes. In fact, I'll just show you my personal cluster right here. You know, I've got 3 Lenovo Tinies, and then I've got a big, you know, smelly in the basement, you know, with lots of terabytes, a big stinking storage, you know. So look, Proxmox can scale with you and grow with you as your needs change, which is one of the reasons I recommend it for this series. But we're not going to be doing that in this series, certainly not in this video. So we're going to disable high availability because we just don't need it. Same goes for CoroSync. We're not going to need that, so I'm going to disable this as well. Now, the script likes you to update your packages in the script. I like watching packages scroll by, so I don't like to do it in the script, and I'll show you how to get around that in just a second. And do I want to reboot now? No, because I haven't updated my packages yet. And the reason I haven't done it here is because there is a slightly special way to do it with Proxmox. Now, by the way, if you want to clear your screen like I did, you can just type Control L. So let me create some rubbish in here. If you want, I see a lot of people typing clear. That's not required. You can literally just press Control L and it will clear the terminal right the way back to the top without having to type anything. And I use it all the time. So first thing we've got to do is refresh the packages from our new non-subscription based repositories that were configured as part of the previous step. Now, it would be tempting here to do apt upgrade, but actually the Proxmox project supply this command called PVE upgrade that does largely the same thing and a couple of other bits behind the scenes that are Proxmox specific. So we'll do PVE upgrade, let the server install all of the new packages, which can take a hot minute. I mean, particularly on this, because this is only an i5 8500 CPU. It's getting on a bit now. It's sort of 8 years old. I mean, it's perfectly fine for media server duties, but sometimes you notice the slowness a little bit. You know, some of the decisions we've made throughout this build phase, we chose an old CPU because it was cheaper. We chose old RAM because at the moment RAM costs more than anything else in the world, apparently. We installed onto a SATA SSD, not an NVMe SSD. All of those little decisions begin to add up with how snappy the base OS feels. It won't matter for our containers and our virtual machines because we're going to put a lot of the things that those apps depend on onto the NVMe drive. But in terms of the base OS, these things can take a hot minute sometimes. Then once PVE upgrade is finished, it's just good practice to run an apt auto remove, particularly when there's been a new kernel installed. And then we are going to reboot our node. Except actually what we're going to do is power off because the next stage is to connect our data disks. And we're going to install MergerFS. It's time we started thinking about our disks. I've just reconnected my data disks. All 4 of them are now hooked up in my system. I can hear them happily chuntering away across the room over there, complete with a fan balanced delicately atop the whole thing. So let's just check that our disks showed up. Let's get back to our Proxmox web UI and just have a look at the disks page. You can see that we've got a few drives have shown up now. We've got our Sabrent NVMe SSD. We've got a Western Digital 4TB drive, a Seagate 10, Western Digital 12, and a Western Digital 4TB as well. Now, in the written guide and explanation, I suggest that you start using a tool called Inxi, I-N-X-I. And the reason I suggest this tool is because it prints things out in a very easy to use manner, but we've got to install it first. So hop over back to your shell, and you can do this via SSH if you want to. If you're not familiar with SSH, it's a way of remotely controlling servers from your terminal. You would load up an app like Ghosty, although you don't have to use Ghosty, of course. And then you would do something like SSH root at the IP address of your server, so 192.168.1.10. It's then going to ask you for your root password, and Proxmox lets you SSH in as root out of the box. However secure that is, it's not very secure, but again, in terms of pragmatism for getting you out of the ground and getting started today, I actually am going to do a lot of stuff with the root user rather than creating a real user. When we come on to Samba shares and Docker containers and having sort of a user to own data files, then the users matter. But I administer all of my servers as root via SSH, but I understand there's a lot of new folks watching this. So I should say that this isn't necessarily the most secure or the absolute best practice. It is, however, easy. It's a very easy mental model. Like I connect into my server as root and I can do anything, both good and bad. So use this with care, because as root, you can do some damage if you screw things up, which you won't, because you've got me here to help you, right? Okay, so we're SSH'd into our Proxmox box as root. Let's install MergerFS. Now, if you're following along with the guide on the website, I wrote a little helper script just to make this easier. Because if we look at the version of MergerFS that Debian provides, which of course Proxmox is built on top of, remember, you can see the most stable version at the time of recording in the repos is version 2.40. However, if you go to GitHub, the most stable version is 2.42. So I've written this little helper script, which basically goes to GitHub and grabs that latest release. So let's go ahead and select yes, and now we've just installed MergerFS. Another caveat, this script, usually you would update packages using apt, so a package manager like apt or pacman on Arch or yum on a Fedora, Red Hat, DNF, whatever. But because we've installed this package manually by hand, it's up to us to remember to rerun this command every so often to keep MergerFS and SnapRAID. We'll do this with SnapRAID a bit later on, up to date as well. So just to verify that the installation went correctly, let's do an apt list MergerFS, and we can see that version 2.42.0 is now installed. So I mentioned inksy a moment ago and I got totally sidetracked with installing MergerFS, didn't I? We want to install inksy as well, inxi, with that same apt install inksy command. And the reason that I like to use inksy for these kinds of things is because it prints out your disks in a really easy to read and understand format. Look, so you can see here that I've got 4 spinning hard drives of various different sizes and a couple of SSDs, and it's just really easy to understand, I think, even for beginners. So now let's figure out how we take those various hard drives, identify, partition and format them, and ultimately mount those hard drives to your system. So let's talk about what mounting is for a second. Mounting is a way for the Linux system to connect to a specific partition on a specific disk. In other words, we're going to tell the OS where we want it to make the data, which is stored in partitions on our disks, available to us for applications to use. The most common layout that I recommend for Perfect Media Server users is to format a single drive with one big gigantic partition to store your data, and then we mount that to a path like /mnt disk 1, and then all of your data lives on that disk. There isn't really a correct choice when it comes to choosing which file system to use. ext4 or XFS are both perfectly fine choices here. Some people will argue that there's a big difference in performance between XFS and ext4, particularly when it comes to large files like we're using on a media server. But honestly, I think in the real world, for most of you, I don't think you'll notice much of a difference between the file system XFS or the file system ext4. It doesn't matter. Literally pick one, flip a coin, pick one, and then choose that. And the reason it doesn't matter too much is because of one of the core tenets of the media server setup. With MergerFS, you can safely mix different file systems together. And it's one of the reasons that I like it so much for a media server over something like ZFS or other systems that lock you into specific things ahead of time. MergerFS will just read a disk, whatever the file system is on it, pretty much, and then put it under your MergerFS mount point. So just create a file system of your choosing and move on with the rest of the guide. So let's figure out how we can map these specific drives to identifiers and disk identifiers on the system. Linux makes available this directory, /dev/disk by-id. And under this directory is every disk that is now physically present in our system. So you can see by running the ls command, we can see an awful lot of output, but we need to find a way to map that output to a specific drive. So let's rerun inksy -xd one more time, and let's try and play this game with SDC as our first victim. Now, there is a command, again, linked in the documentation down below, which allows you to copy and paste this find command to your terminal. This is going to tell you which disk is present on SDC. So you see, if I change this now to SDB, we can see that the Western Digital 12 terabyte shows up as SDC and the 10 terabyte shows up as SDB. Now, the trouble with these identifiers is they aren't stable. In other words, when you change disks or the PCIe devices re-enumerate for some reason, like you change the order of them or you add a new PCIe card, or there's honestly 1,000 reasons why these things can change their name. We want to actually use a stable identifier, and the most stable one and the one that makes the most sense to me is using the physical disk identifier based on the drive model and the unique drive serial number. Now, you could mount UUIDs if you want to, but this one to me makes the most sense. It means that my files are the most readable, recordable source of truth for exactly what these disks are. So now we know which disks link to what behind the scenes. We're going to use a tool called SGDisk. Now, this is primarily for those of you that have brand new drives, or indeed those of you that are repurposing old drives and you want to wipe them completely clean. We're going to run this command here called SGDisk. This command is going to wipe the partition table of our drive, and it's going to wipe the partition table of drive SDC. So in other words, it's going to wipe the 12 terabyte Western Digital disk. Now, this happens to be the biggest disk on my system, so this must be the parity drive. The parity drive for SnapRAID must always be the biggest or match the biggest data disk that you want to calculate parity for. Now, my second biggest drive is a 10 terabyte spinning drive from Seagate here. So by the process of elimination, the parity drive must be the 12 terabyte drive. Using SGDisk, we're going to overwrite the partition table. Now, partitions, you can kind of think of them as logical ways that the file system or the computer uses to store data. They're containers that sit inside the hard drive onto which we put a file system. This is a destructive operation. Do not do this to a drive you want to keep the data for. Then I'm simply going to do makefs.xfs dev sdc. Because we created one partition inside this drive. Now, I'm repurposing a drive here, so I got an error, and you can see that it says, are you sure you want to overwrite the existing data? In this case, yes, I am sure. If this is a brand new drive, you probably won't need to force it, but you know, here we are doing demos on YouTube where things are all smoke and mirrors, or at least I'm trying to make them as little as smoke and as little mirrored as possible, but sometimes needs must. And so now if we want to find the partition we just created, what was the command? Find -l dev sdc. Yeah, this is the one. I actually want to find all of the partitions on this drive. So I will do an ls -la and then copy this in and then do a star at the end for a wildcard. And this will show me that I now have this partition available to use to mount data to. So we now want to create a mount point, somewhere to mount this drive to. And by the way, you're going to have to repeat that step of creating partitions on every new disk that you want to use in this system. Now, there are some commands we can use to speed this up a little bit. So I'm going to use the mkdir command, and I'm going to create 4 directories, although I actually only have 3 data disks. So why don't I change that to 1, 2, 3. Putting it in brackets like this is the same as running makedir mount disk 1, makedir mount disk 2. But if I do it in brackets like this, it does all 3. It kind of loops over them and does it all at once. Yes, you can see I already created them. Now I also want to create parity as well whilst I'm here. So let's do parity 1. And then I'm also going to create mount storage. Mount storage is going to be the main MergerFS mount point. This is what your applications will use to access data. So for example, you would point Jellyfin at mount storage and it would read the data from there. I'm also going to create a mount appdata partition as well, because this is where my self-hosted app configs and data will live. This is where the SnapRAID NVMe SSD will get mounted to later on. We're getting to an exciting point here, folks, where we're going to start to modify the file system table. This file, the FS tab, you might know it as better, is the way that Linux controls which partitions get mounted to which mount points when the system boots. So let's go back to our find command and grab all of the partitions available for this disk and put this string onto our clipboard. Here we go. I'm going to copy this right here because we're going to need it in just a second. So let's do vi fs tab to enter the vim editor. Then I'm going to press Shift G to go to the bottom of the file and press O to enter into insert mode but create a new line at the same time. And just copy and paste the partition into the FS tab file. Now, this is our parity drive, so I'm going to do /mount/parity1. Remember, this is the mount point that we created just a few moments ago. I'm then going to do XFS because that's the file system we picked, followed by defaults 0, 0. Now, there's a full explanation of what this entire kind of syntax means on the Perfect Media Server wiki. So if you're interested, I recommend you go and take a look just there. And to check everything worked, remember we've just done the parity drive for now, but we will do data disks in a minute. We do mount-a, and that will mount our drives to our file system. Except, as you can see, Linux is saving me from myself here. I need to do a systemctl daemon reload, followed by a mount-a. I can then do the command df-h, which will show me that the parity drive is now mounted to my Linux system. Now, another tool you can use for this is one called duf, D-U-F. I just like this one because I think the output's a bit prettier. It's a little harder to read when the font's this big, but in normal use, it's much more pleasant to look at. And you can see that our parity drive is right here. It's got a size of 10.9 terabytes, and we are good to go. We're cooking. So now we just need to go ahead and repeat that process for all of our data disks. So one more time, let's do inc minus lowercase x uppercase d and look for the next biggest drive. So we just did the 12, which was this one. So now we want to do the 10, which is SDB. So let's do find and then modify this whole section to be SDB. Okay, so now we have the name and the serial number of the disk mapped just fine. I'm going to do an fdisk minus L SDB as well, just to see what kind of file system we've got. In fact, it looks like on this one we might already have a file system mounted or present on the disk. So rather than recreate the partitions using sgdisk, and again you can go to the wiki if you want more of a reminder on how to do that, let's just mount this drive straight away to mount disk 1. And we can do that in the FS tab simply by copying this string, doing vi, and then modify the FS tab like so. And then I'm going to assume it's part 1. I didn't check, but you know, I'm just going to assume it. And then hopefully, all being well, I need to do the daemon reload, don't I? Yeah. I can now do mount tac a, and then type duf. Voila! Look at that. Okay, there's not much data on mount disk 1, but you get the idea, right? So we've now got our parity drive and our first data disk mounted to our Linux system. Gosh, this is exciting stuff. So we are really cooking now. We can start to do all of the rest of the data disks and go through. It doesn't matter how many you've got. MergerFS, as far as I'm aware, doesn't really have a limit on the number. I mean, it might have a theoretical limit of like 65,000 or something, but I don't think any of us are running servers that are that big. Now, the last thing we need to do before we can declare victory here is add MergerFS into the mix. So let's go back into our FS tab one more time and just create a new line that looks just like this. You can see using the wildcard mount here, this actually globs together every disk that matches this pattern and mounts it to mount storage using MergerFS. There are a bunch of options here, which again, they're all detailed in the wiki. So if you want to know the nerdy details, it's all in the wiki. But essentially what I'm going to do is just do the daemon reload one more time and then mount -a. And all being well, we should now see mount storage here. Look, this has now globbed together all of the disks available under /mount/disk number. Okay, we've only got one for now, so it only shows us the one drive. But we can start to add all of our data disks under this mount point. Now that was a lot, and it was probably the area of this entire tutorial where there are the most foot guns available. You can delete data if you're not paying attention. You can overwrite partition tables by mistake. So please double, triple check every single command you're about to run before you run it, just to be sure you're not about to delete your life's photos or something. God, I would hate for that to happen. Please be careful. This is a risky section. And if you're not sure, please refer to the documentation over and over and over again to make sure that you're sure before you delete anything or create a new partition table by mistake against the wrong drive. It's easy to do, and in my formative years doing all this stuff, I deleted quite a lot of data by mistake whilst tinkering around with this stuff at the beginning, so I know how easy it is to do, so please be careful. Right, so we've talked about now how to store the data using MergerFS and how to access it and create, a single merged mount point across drives of different sizes and make that all work nicely together. It's time we started thinking about how we protect that data using SnapRAID. In parts 1 and 2 of the Perfect Media Server, we discussed hard drives and why these things are fickle and dangerous and little buggers. They're out to get you, to be honest, and they will fail. It's not a question of if, but when. And so we need a tool like SnapRAID, which is going to create a set of parity data for us to fill in the blanks when one of these disks fails and rebuild the contents of the media or the data that was stored on that disk at the time of failure. And SnapRAID is aimed at home media users where files are typically written once and rarely change. Now, much like MergerFS, the most modern version of SnapRAID that's in the Debian repos at the time of filming is version, let's have a look, SnapRAID version 12.4. However, if we look on GitHub, the most recent version of SnapRAID is version 14.6. Thus, I make available a script, again linked in the documentation down below on the wiki, available at perfectmediaserver.com, to install SnapRAID. Much like MergerFS, this isn't being installed through the typical apt repos method, and so it is up to you to run this script periodically. You can use a systemd timer if you want, and we cover that on the wiki as well, just to make sure that this package stays fresh and stays up to date, perhaps using something like a simple systemd timer. So since this video took me so long to get out the door, over a year, I think, since I started the Perfect Media Server video series, SnapRAID's been busy on their development side. As you might notice, look, we have not only the SnapRAID package, but there's now also a SnapRAID daemon as well. The creator has created a new web interface for SnapRAID, so you can actually log in and manage your SnapRAID installation via a web UI now. But the other thing that means is that we don't now need something like SnapRAID Runner. Now, SnapRAID Runner was useful historically because there was no mechanism built into SnapRAID to automate the runs of the snapshot parity calculation. Now, what's snapshot parity? Well, the difference between SnapRAID and, say, ZFS or Unraid is that ZFS does a stripe across all of the disks that you have in like a Z pool or a ZFS RAID 1 or RAID 2 configuration. And so each drive contains a small slice of the parity data. Thus, if you exceed the fault tolerance amount for a ZFS or a traditional RAID array, you lose all the data on that array. Unraid is probably much closer to SnapRAID, but it's done in real time versus snapshot. Unraid is different because it has a single, or multiple, like SnapRAID. It has like a concept of a single parity disk where all of the parity data actually lives. Each data disk, much like Perfect Media Server, remains individually readable, and it has its own unique, distinct file system, which includes the parity drive as well. The difference between SnapRAID and Unraid, though, is that Unraid calculates that parity in real time whenever you make a write, whereas SnapRAID, hence the name, does it on a snapshot basis. It's up to you to run the sync every day or so. And I cover that in great detail on the wiki and in parts 1 and 2 of this series. But what the new SnapRAID daemon allows us to do is get rid of those external scripts like Cronial's SnapRAID Runner that we used to have to use to configure an automated sort of wrapper around SnapRAID, and it's now built right into the core of SnapRAID itself. Pretty cool. So first things we need to do is create a snapraid.conf file on the root of our system. So let's use vim again, and we'll do vi etc snapraid.conf. And then on the wiki, I'll bring this page across for you. There is a page here which has everything that we need. Now this section here, the SnapRAID configuration file, this is what we're going to copy into our vim file first of all. So let's put this over here and paste this in. Now, we only have 3 data disks, and of course you're going to have to modify this file a little bit depending on what you name things, depending on how many disks you have. what you want your excluded files to be and all that kind of stuff. And in SnapRAID version 14 as well, they've added a new option to do is it .SnapRAID ignore or .SnapRAID excluded or something. It's pretty cool. So you can couple that with the commonly excluded files in your .conf file and generally have a much better experience. Some of these updates to SnapRAID are pretty nice. You know, see, sometimes it's worth waiting to release a video for over a year. Next up, we want to configure the SnapRAID daemon, and all we need to do is edit this file here, etc SnapRAID daemon. And this file looks a little more intimidating, but really it isn't. And again, on the wiki, like with much of the rest of this series, there is a full overview of all the different parameters and sync thresholds and updates and deletes and stuff like that. All the nerdy stuff is on the wiki should you want it. But essentially what it boils down to is we just want a couple of things. We want to make sure we can access the web UI from any node, like over Tailscale or any other remote access tool, and make sure that the net is enabled as well. So let's go ahead and do that real quick. So let's do a search in Vim by doing / and then net_enabled, which should take us to the relevant section. Here we go. Net enabled 1 is already set, but net port is not. So let's do a DT : delete till : I suppose I could have done DT7 to save myself a keystroke. And this will put the SnapRAID web UI on, basically it's doing 0.0.0.0 like this, but it's just a shorthand way of writing it. So we basically just want it to look like this, net port 7627. Now, one thing I want to point out as well is that there is a notify heartbeat option here, which allows you to do things like calling remote health check sites, like I cover in the perfectmediaserver.com article. There is a website called healthchecks.io, and sometimes it can be handy to have the SnapRAID runner, or indeed now the SnapRAID daemon, call out to these websites and ping them every time a job completes and send the logs, or most importantly, alert you to whether there has been a failure or not. We're not going to set that today, but there is an option to do that in the wiki that is linked down below. And with that, I think we're pretty much ready to go. So again, to quit Vim, you press escape, press : do a WQ for write quit, and then we will do a systemctl daemon reload because we modified a couple of files just to be sure. And then we will restart SnapRAID D just to pick up those new changes. Now we're running on 192.168.1.10 and then 7627. And there is our SnapRAID Commander dashboard. There is a fantastically vibe-coded dashboard, if ever I saw one. Here's the tell right here. I mean, you can just tell just by looking at it. But anyway, I'm not saying that's necessarily a problem. It's just something to be aware of, I guess. Some useful commands in here, honestly. I mean, you'd have had to drop to the terminal to do this before. We can do things like starting, where is it, disks. I'm new to this myself because I only figured this out yesterday when prepping for this video, that there's been all sorts of changes and updates happen in the background. So I can actually hear the physical disks on the bench spinning up and doing stuff in the background. Now, of course, the array is completely empty at this point. We're going to sort that out in a minute once we've configured Samba. But we have just done it. We have automated our SnapRAID. Well, we've automated the SnapRAID parity checks. So these will happen every day. What did it configure as its default window? We can find that out by looking up maintenance schedule. Yeah, there you go. So it's going to run every day at 2 AM. I think that's fine. Just bear in mind that that window of time between when a file gets written and this specific time of day, that file will be unprotected by parity. So if your drive fails in that window, you will lose what's on that disk. The other thing that I didn't talk about in terms of SnapRAID being a benefit over more traditional RAID is that if you exceed the fault tolerance of an unRAID or a SnapRAID, rather than losing the entire contents of the array, you only lose what's on the disks that have failed over your fault tolerance number. So again, because those disks remain individually readable with their own individually readable file systems, it's just nice. It's flexible. As I keep saying, it will grow with your needs over time. You know, if you find a good deal on a used hard drive on Facebook Marketplace these days and you feel like you just want to pick one up this weekend, you can do that. There's no massive resilver times or RAID rebuild windows, and like literally I could just take this drive pop it into the server over there, and I'd be good in just a couple of minutes. Create a partition, format it, add it to my SnapRAID config, and I'm done. It's honestly, for a media server, I still maintain there isn't a better option than SnapRAID. Okay, it's time for Docker. Let's install Docker. Now, the easy way to do this is curl fssl https get.docker.com and then pipe this to shell. Yes, I'm a nerd that's memorized that because I've done it so many thousands of times in videos on the Tailscale channel over the years. But installing Docker is really actually very straightforward. And running your first container is also very straightforward. We're going to make Jellyfin our first container. It is Jellyfin June after all. But before we create Jellyfin, we should probably make sure that our app data has somewhere to live. Remember, right at the beginning, we created the mount app data mount point under /mnt right here. Well, we need to map that to a physical disk underneath. And we're going to use the NVMe disk here, this Sabrent NVMe 0N1 disk. Again, see, I'm using the same commands, but I'm applying them to a slightly different problem to get the results back that I want. So the first thing we're going to do is use wipefs to basically clear out this disk and just make sure there's no old partition signatures on it or anything like that. Then we're going to use sgdisk just to zap all and do the same thing. Again, just to clear this out. Okay. And it says you may now partition the disk however you would like. But we're not going to use XFS or ext4 for this. We're going to use ZFS. Ooh, scary, I know. It's fine. It's really not scary. But we want to create an array or create a Z pool, actually. It's a single drive Z pool, which one of the people kind of confuse ZFS with RAID and redundancy and all that kind of stuff. And it absolutely is fantastic at all of those things. But you can run ZFS in a single drive array. Now, if you have the number of NVMe slots available and the number of drives available, by all means, go ahead and run ZFS in a mirror. We don't have enough slots available for us to do that today, so we're going to have to get a little more creative and just do a single drive ZFS pool. Now, I'm going to use this command here of zpool create. I'm going to set A shift 12. This is a way to line up the partitions on the disk with the blocks on the drive. This is an immutable option, so you must set it correctly when you create the pool. Mount app data is where the ZFS pool is going to be mounted to on the physical server. And then all the rest of this stuff is really boring until we get to app data here, which is the name that we're giving to the Z pool itself. So I had a trailing quote. Yes, of course, I need to specify the disk, don't I? Otherwise, how does ZFS know where to create the Z pool? Okay, and there we go. So now if we do a ZFS list, we'll see that we've got a new Z pool available to us. And the reason that this is useful for us for app data is it allows us to back up these volumes using things like ZFS send. It allows us to do snapshots before we upgrade things and stuff like that. I think that's getting a bit beyond the scope of today's video, but I wanted to show you really the coexistence of ZFS, ext4, and XFS all on the same system. No licenses you had to purchase or anything like that. It's all using completely free and open source software in the truest sense. And doesn't that give you a warm and fuzzy feeling? I know it does for me. Maybe I should get out more. But because we configured the mount point of /mount/appdata, this means that we can now do ZFS create appdata, and then we're going to call this one Jellyfin. And now if we do a ZFS list, you can see we've now got a new data set under mount appdata Jellyfin, and we now have somewhere for our app data for our Jellyfin container to live. Remember that? We were talking about Jellyfin a minute ago. So let's create it. Let's use Vim again. We'll do vi compose.yaml. Right now I'm in /root, just my root user's home directory. Some people like to put compose files under /opt or perhaps even under the mount app data folder right here. Totally personal preference. I just put them in root again. Like I'm always logged in as this root user, and it's the same thing across all of my systems. So for me at this point, it's muscle memory. If you want to do it differently, that's cool. Like no judgment, whatever. Like it's totally up to you. But to deploy Jellyfin, this is it. This is how complicated it needs to be. In fact, I have an extra word right here that we don't need. This is it. It's what? 12 lines of config, and we're deploying a full-on Jellyfin server. So let's do this and do a docker compose pull. hopefully you're starting to see now that, but you know, by the time you get used to the command line, I know some people find it intimidating, but this is a very reproducible way of building a system. Like, there's been no very, very minimal click ops, I should say, certainly compared to many of the other platforms available. No licenses, like I say, it's all completely free and open source software, up to and including Jellyfin. And so now we can go to 192.168.1.10, and then Jellyfin's on port 8096. Yes, there we go. Now, because we didn't specify a host name in our compose file, in fact, let's fix that, and I'll just show you how to fix something on the fly. Let's do this, and we will do a host name, and we'll call this one, well, why don't we call it PMS Demo? Why not? What a creative name. When you make a change to the compose YAML file like that, it will pick up the changes when you run compose upd again, and then it will recreate the container with those changes in, and you can see now the server name has been picked up. I didn't type that, it just did it by itself. So then we just go through and create ourselves a simple Jellyfin media server. Really, it doesn't need to be more complicated than that. And we're going to add our media library, which doesn't actually yet exist. We haven't copied any files across because Samba hasn't been configured yet. So I suppose we should do that before we configure the rest of Jellyfin. So let's now configure Samba. Now, Samba is a way of accessing files over the network. It originally came, I think, from Microsoft back in the day. You've ever heard of CIFS utils? C-I-F-S? CIFS, Samba, it kind of all means the same thing. There are different versions of the Samba protocol, because this thing's been around decades at this point. Another common one you certainly will see on the wiki, but I probably won't do in this video just for time, is NFS. It's a much more Linux-friendly option. The thing I like about Samba in particular is it's just supported everywhere. It works on macOS pretty well. I mean, all the video files that I record onto this laptop for this video, I transfer back to my NAS over a 10 gig SFP connection, and I get full 10 gig line speed. And again, on my editing laptop over there, I pull them off and edit over Samba as well. It gets a bad rap sometimes for being a noisy protocol and a bit slow, but honestly, my experience is, it's not been perfect over the years, of course, but often it's down to hardware issues and cabling issues more than it is down to Samba itself. Whereas NFS is, it's not like it's less well supported, but I don't know, it just doesn't seem to have quite the same level of ubiquity that Samba does. So choose your poison, or even install both. ZFS even has native Samba share options built right in as well, so you actually sometimes don't even need to manage the Samba configuration file. But let's get Samba installed onto our perfect media server without any further messing about. On Debian, that's just a case of doing an apt install Samba, which just takes a moment or two. Now, we haven't yet created a local user, and when we're connecting into Samba shares, we don't really want to be doing that as root, because we're making that available over the network, and typically I run my Samba share inside my LAN without a password. I don't know, like root as Samba, it's just a bit too easy to go in through a smart TV or something like that. So I'll do this command here of add user ironic badger, and this will add a local user on my Proxmox box of ironic badger. Again, I'll just set a password. This is not the Samba password, this is the user password. So if I wanted to log in as this user instead of root, I now could, which is kind of useful if you want to do that. I'm not going to do that though, but what I am going to do is make sure that all of the files under mount storage, and again this is all documented in the guide linked in the description down below, I'm going to make sure that all of those files, of which there are 0 files, are all owned by my user and that they all have the correct permissions. And then I'm going to make sure, well, there's no files, even though I'm just going to follow it because it's in the wiki. But if you had files, this would make sure that they had all the correct permissions and stuff like that. And then finally, we want to get the user ID number for Ironic Badger, which is 1000. Now, you might need this UID of 1000 if you're running into any kinds of permissions issues. So currently, we are running Jellyfin as the user root, whereas it would probably be ideal to run Jellyfin as the user 1000 or any of your other apps that are accessing data on the host as the user 1000, just to keep permissions straight across the place. This is getting into quite advanced territory, and permissions can be really confusing, particularly as a newbie, which is why I kind of have steered towards root for so much stuff so far in the video. But with Samba, it is kind of unavoidable to create a user. So that's what we're doing here. Now we're going to create this file here of /etc samba/smb.conf. And I'm just going to delete the entire contents of this file by doing a D-Shift-G and then paste in my own version right here. And this isn't Cartman, this is PMS test. And there we go. So we actually don't have Alex, do we even? I should change this to Ironic Badger as well. And everything else looks good. So I'm going to write out this file with Vim. What else do we need? Yes, we need to set this Samba password. SMB password Ironic Badger. And this is so that I can connect into the Samba share over the network with this username and password from my Samba client, whatever that happens to be. So let's do a systemctl restart Samba daemon SMBD. And now what I'm going to do is just load up the Finder. Where is it? I can't find the Finder. And then I'm going to do a Command K. On macOS, this is how you connect to remote servers. And I'm going to do 192.168.1.10 and connect to that. And all being well, this came up on a different screen because macOS does that for reasons I still don't fully understand. I'm going to put in my username of Ironic Badger and the password that I have and connect in. And I am offered the choice of mounting the Ironic Badger home user folder or storage. So we'll do storage, and we already have a media folder because we started Jellyfin, so it created something. So let's just copy across from my real NAS. Let's just copy across a couple of movies and TV shows just to get the ball rolling. I mean, this might look trivial to you, but I'm copying across, you know, nearly 100 gigabytes worth of data, maxing out the gigabit link on that system over there. I can't hear it. Like it's. I mean, I can hear the hard drive gently ticking away, like hard drives seem to enjoy doing. But this is the perfect media server in action. Just in the space of these few minutes. What's this video runtime at this point? Probably an hour or so. And thank you for sticking with me if you're still with me. My goodness, it took me a good couple of days to record all of this footage, and I am incredibly grateful to those of you that have watched this far through or that have read the perfectmediaserver.com article. But we are now transferring movies and TV shows to our own NAS using nothing but free and open source software that we haven't paid a penny for. Doesn't that blow? I mean, it blows my mind a little bit. I just think it's the coolest thing. And since I wrote the very first Perfect Media Server article back in 2016, it's kind of fitting I'm doing this video in 2026 now I think about it. You know, the 10th anniversary edition. I should slap a logo on it or something. 10th anniversary. It is amazing to me that this is even possible, really. And I know I've been giving Plex a hard time lately about their enshittification and stuff like that. But really, it's because I've been doing this stuff for so long, and Plex has just been part of the wallpaper for me. And trying out Jellyfin this month has been actually kind of fun. Like this Perfect Media Server Part 3, like I figured it was a good idea to give people a way to actually run this or show them how to get out of the ground and build their own Jellyfin server from scratch. And that's what this video has been, hopefully. So we've basically finished the article at this point. What I want to do, though, before we get out of here is just show you the final step of adding media into Jellyfin. Now, it's going to take a few minutes for these files to copy across, so I'll be right back when it's all finished.
A few moments later.
The file copy is complete. I want to show you another tool that I often use in these sorts of situations called ncdu. So let's put that against mount storage. Now remember, we don't have any concept here of which specific disks MergerFS decided to put the specific files onto. So let's have a look under ncdu, and we can see that in TV we've got 25 gigs for the thick of it and so on, and we didn't have to worry about which disk. But if we do tree mount disk 1, you can see that there's a few files here, and let's do mount disk 2, and there's a few files there, and on disk 3 again there's a few. So things get spread out all over the place underneath, and you as the user just don't need to worry about it. And let's just, for the fun of it, let's do a SnapRAID sync just to see what happens now we actually have some data on the server. Whilst that sync is running, because it will take a couple of minutes, let's go back to our Jellyfin configuration and let's add the movies library. So I know I'm going quickly, but you know, it's the end of an hour-long video. Let's get it done as quick as we can. So media movies, remember that was mapped through to the container underneath. So movies is now added. Let's do content type shows for TV. I always want TV, I never want shows, but hey, personal preference, I guess. And TV, there we go. Going to click on OK. And now it's going to start a quick scan, hopefully. I need to get logged in. Yeah, fine, whatever. There you go. My media server is almost perfect, and it will be perfect if SnapRAID is running. There you go. You can see SnapRAID is now calculating some snapshot parity for the data that we've just put across those disks. So if one of those 3 data disks was to fail now, and I could replace it in a timely fashion, I could rebuild the data that was on the disk that just failed using the SnapRAID parity if I wanted to from the last snapshot. Oh, this stuff is so cool, man, I tell you. And there you go. So now we can go and watch Milton to our heart's content or whatever we want. I don't want to get a copyright strike, so I will not do that. I will not play that. But our perfect media server is now perfect. We did also probably want to enable hardware acceleration. Where is that? Under general, playback, transcoding, hardware acceleration, quicksync, because I don't know if you noticed in the compose file on this system, I slipped in this little line here of dev DRI. That's all you need to do on the Intel platform these days to enable quicksync. Like, it's just so easy. It's so easy. Select that in Jellyfin, click save, and then this kind of annoys me with Jellyfin. Like, I need to go back to the dashboard and then restart Jellyfin every time I make a change. But yeah, there we go. Perfect Media Server Part 3. I promised you it would come. I didn't say when. I don't think I intended it to be a year either. But, you know, to be honest with you all, after I made parts 1 and 2, we listed this house and decided to try and move back to England to try and sell this house. I'm still here. But in that meantime, we have had the house on the market now for sort of 9 or 10 months. And I've been trying to sell the house, and a lot of this stuff has been in storage. And I just finally decided with this Jellyfin June thing, it was worth going through the unit and trying to find and unpack all this stuff to bring this video to you all. So yeah, it's been a heck of a journey. It would mean a lot to me. I very rarely ask for a subscription, but if you've watched this long through the video, please consider giving me a like, comment, a subscribe, all that good stuff. It would mean a lot. You know, this video took a long time to put together, and the Perfect Media Service series has taken a long time to maintain over at perfectmediaserver.com as well. And just let me know. I want to hear from you. Like, has this? I hear from quite a few people over, you know, in dribs and drabs over the years that this stuff is useful to them. But is it genuinely useful to you? Do you get a kick out of it like I do? Just building a completely free and open media server just out of open source software. I just think it's the coolest thing in the world. Yeah, I don't really know what else there is to say. Yeah, perfectmediaserver.com. Check the links in the description. And thank you so much for watching. Until next time, I've been Alex from KTZ Systems.